speaker is someone who's outstanding, as always. He has nearly a quarter of a century of tech experience. Sorry, it was in your bio.
You could have done it in seconds, maybe that would have sounded
With nearly a quarter of a century of IT experience, he's also a patent holder for a method to convert XML data structures into relational databases. In his former roles, he was a consultant for Sun Microsystems as well as the chief architect for a Wall Street brokerage. Please welcome Chief Field Architect of MarkLogic, Ken Krupa.
Okay, so there's actually books. Okay, now I know how American Idol people feel the right distance. So there's actually one more trivia question before we start. And this is a video daily thing. Okay? Can you guys hear this? It's cutting in and out? Right? Okay, so I'm going to escape out of this. I said I'm going to escape out of this. How about we exit the show? Okay. Video daily double. First you have to listen.
Please. Computer. Computer. Hello, computer. Just use the keyboard. Keyboard. Oh, great.
Hey, real quick, what movie?
Star Trek.
Okay, there's like 17 of those, so what was it?
Boy at home.
All right, who said first? Well, okay, you did. Okay, T-shirt. Where are we going? Okay, these are the logistics of presentations. Okay, great. Now we're back on track. All right, so this slide here is something that internally that we've shared. And when you first arrive at a company and you see some of the architecture, you're like, okay, that's architecture. But this one actually resonated with me because if you remember, I've been in this profession for a quarter of a century. And if somebody can count that in microseconds, maybe we'll do a t-shirt first when we do it. So this resonated with me because it talks about the data management evolution. And it sort of puts it in three different eras, right? And the first one we could call the file-based era. And I left college learning this cool, relatively new language called C. I had a first edition of Kermit and Ritchie. I had it highlighted because that's how you did stuff. You actually had a highlighter and highlighted it. And I left and I said, in my last semester, C in Unix, and now I'm going to go out and do that stuff. And of course, the first job I got was doing mainframe programming. And in mainframe programming, all of your data was in files, for the most part. And some of these files were hierarchical files, and some of them were flat files. But what you did is if you wanted to find out stuff about the data, you wrote a program. So like you had to sit down, write a program, and say, hey, the answer is 42. The gentleman over here did. And that's what you had to do. And you print reports and give them, or you would look at them on a green screen, and that's how you got information out. That actually worked, and IBM made a lot of money doing that. But then we decided that was kind of too much of a friction point, right? We couldn't wait for everybody to run the program every time we wanted to answer a question, because what we wanted to get to was simply asking the computer a question, just like Scotty did over there, right, and getting an answer, right? So that wasn't good enough. So what happened next was the relational data, and in this case, all we had to do was get all of our data into one place being a database, and organize it into these rows and columns every now and then. And once we did that, if we used the standard language called SQL, we could ask questions on an ad hoc basis. A little better, a little closer to the computer, a little closer to picking up a mouse, And that was fine. But every so often, right, when you identify new data, you had to model, right? So that was the price we paid. We had to model this stuff, figure out the universe of questions that we wanted to ask. Okay? If anybody could tell me the exact perfect distance, it's Mike, 2 t-shirts, okay? With that. So in this case, this worked great. But then something interesting happened, is the more we asked questions, the more we wanted to create applications that worked off of these relational databases, and then this thing called the internet came along, and then we started creating more data. Maybe they were backed by relational databases, but they emitted more and more stuff, we want more and more questions, and this data began to look unstructured. Because of so much of it, we entered this big data that we're in today. And it's different because here we were schema dependent, but what we found out was that we could no longer wait to model before we answered the question. We just need to know now. Right? Twitter feeds and all sorts of unstructured, semi-structured information, and we wanted to get the answers more quickly, and there was so much more data. And that's where we are today. Right, so in this big data era, and that's what we're going to talk about. So I'm going to do another obligatory presentation thing. It's called the show of hands straw poll. Seen this before? Okay, and this show of hands straw poll is going to be a little easier because I'm going to give you 2 choices. All right? And whenever I'm asked these, I do great. Sorry. How's that? Oh yeah. See that? Definitely American Idol stuff. So the show of hands, straw poll. I know whenever I'm asked these, I kind of do the sideways. I wait to see what everybody else is going to answer. But all right, show of hands. If you are a technical manager, where your responsibility is mostly to not so much code on a daily basis, but to manage the delivery of applications, but you do most of your coding in your spare time because you get paid to watch other people code, and you use the code. Raise your hand. Okay. The other category, I'm hoping this is the binary thing, is you code all the time, and that's just what you do. And then there's everybody else. I'm curious what everybody else thinks. Okay, good. So we're going to do a walkthrough. Now, this is mostly an architecture thing, in that we're going to look at a lot of different things. There's going to be some pictures on here. And we're going to try to arrange how they put together. Oh, by the way, these days I fall more into the form category, but I still code as much as possible in my spare time. So, okay, so for those of you who, this might be the 1,000 different 3 V's slide that you've seen, but it's important because it actually does capture it. Every now and then, the industry comes out with a good definition. And the reason why it's up here, right, so the 3 V's, volume, velocity, variety, you've probably heard that, right? There's a lot of data, all of it looks different. The velocity I want to call out because it's an overloaded term, because in addition to getting it really fast, there's also we want to turn around results quickly. We want to fail fast. And that's as well as we want to do our calculations quickly, right? So it's kind of loaded. Sometimes you may not have a lot of data, but you need some agility to deliver the results more quickly. Or maybe it's a variety issue, but I want to know tomorrow and you don't have time to model or code. So that's why I want to call that out. And then many of you may have heard that there are other V's entering the space. Just ignore that. It's like V, what should I call it? It's all the value or veracity, viscosity, like it's motor or something like that. So just forget that. 3 V's, they actually did that like it, and it doesn't make sense. So for those of you who are familiar with the Hadoop ecosystem, we're going to scope it down because when we draw architecture diagrams, this really nails it, right? If you see some Hadoop diagrams, like, so this is a cheat sheet, this is a not so cheat sheet, and this one is meant to amaze and confuse and maybe intimidate, but really, if you're thinking about, well, what is Hadoop? It's basically this very scalable file system with some software that runs on top of it, and this meta algorithm that I like to think of as just massively scaled simplicity. It's a meta algorithm because it's not a specific algorithm you have to implement. So you have to do some shuffle steps, but it works. It works by brute force, right? So that's really easy. This is hard and confusing. It's easier to think of it as this file system, this place, which is actually, we'll talk about later, point of integration for a lot of technologies today. All right? So let's talk a little bit about the way people used to work in Hadoop like this, right? You actually, and in this example, we've got weblog, right? So let's say you start with a population of raw data, they're weblogs, and you say, okay, I want to look for the query stuff, because I want to do some sort of intention analysis, see what people are interested in. So I'll take that stuff, I'll run it in HDFS, I'll write and run a MarkLogic job, and then I've got some signal, I'm going to put that somewhere so that somebody can combine it with some other data that they have. And, okay, that worked, because we could process amounts of data that we couldn't process before, but it was a bit, in some sense, right? You had to hand code, right? Java, it's not really all that printable, though some people may a differ. A lot of the early evolution was around how to make it work, how to do the carrot feeding, right? There were things like, let's eliminate single points of failure, like name node, and we got shard stuff and have this node to data affinity, but it tackled the volume issue, and the variety was great because you just dump the data raw and you take it out. But there's one striking point about, if we think back to our first era of data management, a t-shirt, anybody want to? Okay, right, but velocity, but what specifically about the velocity? What are we doing here that we did a long time ago that we stopped doing in the relational era?
File structure, using the file system.
Right, well, okay, we'll take that, right? We wrote a program to answer a question. All right, well, that's close enough. File. We'll go with that. But we dealt with the files, and the file system itself isn't bad, but we had to write a program to look at the files. And that's not what we want to do, right? That's so in some of these. But it was a worthy trade-off because Hadoop went to places that you couldn't really go to from the scale standpoint, and you didn't have to spend a lot on sand or anything like that. It's relatively, it's commodity hardware. But, okay, so here's the answer. Only part of the velocity dimension was covered because we went back to writing programs. Okay, so there we go. So what happened, right? The ecosystem began to expand. We had these higher level of abstractions like pig and pig Latin, right? So instead of writing and compiling Java code, you can script stuff in pig. And then, of course, Hive came along. I think the folks at Facebook were the ones who came up with this. And Hive introduced the concept of schema on read. We could always do raw data, but now we can put this schema, we can decorate it with the schema, and the only widely used standard that we can say we have in the analytics space, and when I say widely used, I mean like really ubiquitous, is SQL for now. And so that was great. So now we can put this on top of our Hadoop and write some SQL and get our answers. Well, where are we today, right? So now we're going into this, well, Hadoop is very batch-oriented. If you've ever run a sort of like a simple aggregation, right? Let's say you have a huge cluster and you have an aggregation of 1,000 rows of data. It's still going to take like maybe 20 seconds. It's going to fire off the MapReduce job and say, I only need to run one map job, and you're going to get log output, and the 42 is going to come, right? But if you did that and scaled it to billions of rows, it scaled really well, and that 20 seconds was nothing compared to the job that used to take a week that now runs in a couple of hours. But in business analytics, there's this 30 seconds response time for everything doesn't quite work. So now we're seeing these real-time alternatives, and they're relatively new, right? So Apache drill, which is like the answer, the community answer to the Google Dremel. Impala thought they was coming out with that. I think there was an event. Room looked like this one, except completely different, just a couple weeks ago. And then where we are, right, we have the MarkLogic logo, NoSQL interoperability, right? And that's the segue into our next page. The NoSQL cheat sheet is a little bit, it's not easy, right? The thing about NoSQL is it's, anything but relational is kind of the term. If you could save data, so by that definition, a file system can be considered NoSQL, but we'll say this is a little bit more than a file system. And there's a categorization here that there are lots of categorizations of NoSQL, so this is my attempt based on many that I've seen on the web. But we'll start with the basic one, the key value. It's a hash table on steroids, if you will. And in fact, I even have a predecessor column, which is called. These kind of existed before there was a definition of the space, and there's nothing new, right? The ideas often go back decades. So the examples are, DynamoDB is it's a little brother, I guess. Redis and React. There may be other examples. So if I forget, there are so many, or if I don't know, forgive me, we can do endless searches. But then, so this key value is just like take a key and stuff anything in it, right? Not primitives, but arrays, whatever you want. Just stuff it in there and pull it out. Right? Then there's this slightly more modeled version, which is the columnar store, and these are where the data types are primitives, or primitive right for the most part. HBase and Cassandra examples, but Sybase IQ, a relational, purpose-built relational column store, goes back, predates these by quite a bit. And these are good for value crunching, like Furious. That's a good example where you just have lots of little rows of data, numbers, whatever you want to crunch into time series, and all the things that make these quants and actuaries happy. And then there's the document store, right? And this is where we are. And this is where, again, it's key value. You have a key, and in our case, it's a URI. And you put something representing a document. And what we do is we have XML and JSON now. And you get a much richer context, right? So things that would be considered maybe 3 or 4 tables if you shred it in a relational. Let's say parent-child composition. You can put that all into a document, right? Repeating groups, you can put them in there, right? Think of XML, XML. And that's good because it's quite a ways closer to the object models that we've been working with lately, right? But of course, these have their predecessors, right? For years, when XML was kind of hot, everybody was like, oh, let's figure out how to shred XML into a relational database. And in fact, Eric talked about a particular patent I have, which for the most part we don't need if we have MarkLogic, that shreds XML, puts it into a database, and we can also use a query. And then, of course, I put MarkLogic here twice, right? Because we've been around for 10 years. So we kind of were there before NoSQL was defined. Now that NoSQL is defined, we fit very well into that space. And then lastly, the graph databases. I see these as just an object cache, again, on steroids, right? But relations and pointers to other objects are made easily in these particular database types. And here's some examples. And of course, object caching, where you have some persistence going on to back it up as a processor. And then Prevailer is something that's still around, and I don't know whether I'm going to put it here or here. It's something that I remember reading about before NoSQL came in. So that's the NoSQL cheat sheet. Not as neat and tidy as the Hadoop cheat sheet, and pictorially it looks like this. Right? And my message here is RDBMS is just the structured stuff. Pre-model it. Here it's like you don't necessarily have the model, you have the model later, and it's everything else. I've heard statistics or these sort of like rule of thumb statistics, and I don't know how accurate they are, but 80-20 is like a good thing people like to use, the 80-20 rule, but I do hear often that 80% of the world's data, I imagine somebody looking at that data, okay, I'm counting it, but 80% of the world's data is unstructured, and most of that, I think, upwards of 90% was created in the last 2 years. So, exponential progression is something very common in space, right? Okay, so where does it fit in, right? We're going to be talking about architecture a little bit. The difference between, say, a NoSQL database and a real-time Hadoop accelerator is that you get read-write capability, right? So a full CRUD operations. You can create stuff, delete stuff, update it, right? It's different. It's a database. It's not just a query engine. But you can do that at scale, right? And you build applications in that. And the other key thing is we can develop applications more quickly, right? Because if you've been doing anything in an old language, saving to a relational database, you're likely using a framework of requirement. So let's say you're coding Java, you're probably using like Hibernate, Betas, and you spend a lot of time, avoiding the nuances of the relational database, even though that was the engine you're using. So here, you don't have to deal with, all the impedance mismatch. If there are real electrical engineers in the room, not long, they'll probably stop. Impedance mismatch is something else, right? But that's what we call it. And the other point here is that there's multiple ways in which to interact with these NoSQL databases. And part of that is because, well, why not? But part of it is really by necessity. There is no standard way to get data in and out of these databases. There are some emerging patterns, and there are actually dialects of SQL sitting on top of these NoSQL databases, and we do that ourselves. But what we'll discuss a little bit later is that SQL by itself is not enough. It's a great start. And it's the only really ubiquitous standard we have for business intelligence, but we need more. This last point is interesting because Hadoop has become the de facto, meeting place ecosystem for lots of data. We'll talk about that a little bit in a moment when we go over some examples. But it's kind of an expectation. If you're doing something with NoSQL, there's a checklist item somewhere saying, well, what's your Hadoop story? What do you do with Hadoop? I don't know. But we'll talk about that later. So that's kind of where it fits in. We've got Hadoop on one hand, right? It gave us this massive scale, this file system, if you will, and amongst other things. And then we've got these NoSQL databases. We're going to talk about these two pieces and talk about them in an architecture perspective. So this is another thing that dates me. My cord is tree. Is it happening again? Is it the batteries? Okay. How's this? Okay. So the data warehouse. So my wife and I, we met at work, second job ever. And she still remembers the stuff I used to do. She goes, oh, data warehousing, isn't that what you did like a long time ago? And I go, yeah, that's right, good memory. Data warehousing, I remember when this became a hot thing. It was before the internet, guys by the name of Bill Inman and Ralph Kimball came up with this idea of a star schema. And it was because the third normal form relational model didn't quite work for analytics. So we built these data warehouses. And so what I'm going to do is I'm going to walk through what we would call a traditional data warehouse, because the technology and the pattern has matured. And then we're going to walk through how it's changing with some of this big data stuff. So when we do these things, it's helpful to have a pattern, right? So most data warehouses, they fall into this pattern, right? Where you have your data sources, you got to take it in, you store it. So you take it in, you convert it, you store it, and then it's the analysis, but you may also do some feedback and enrichment, okay? So I'll do something with a little bit of a swimling thing here, and we'll walk through a traditional data warehouse, right? And over on the left, we've got our internal database, internal files, some external systems and web stuff, and then we've got our ETL process. And the ETL process is something that you have to code, right? Because you have to shred unstructured data, figure out what mentions you want to analyze, and you create the star schema. The star schema would have a fact table and a bunch of dimension tables around it, so you can do 18 different dimensions. And we previously pre-joined this stuff, but now you have this table that you can slice and dice every which way. You run back processes off of that, and you do some ad hoc analysis on it. On the main data warehouse, well, you might have some specialized needs that would require other data maybe for a line of business, and you create these data marts. And that's where maybe the lines of business would do their enrichment. And when you did that, you had to do some other ETL, right? ETL for those, I shouldn't say everybody was out there, extract, transform, and load, and another chance to give away a t-shirt. There'll be others. And this is still in use today, except now there's this NoSQL approach. The NoSQL approach is, okay, here we go. The traditional vendors not quite giving up, and not that they should, but just saying, well, you know what? We'll create this purpose-built hardware, software appliance and let you massively scale your data warehouse. It'll still be SQL, but you'll be able to crunch the numbers more quickly and do a lot more. I think things are good because they do all kinds of optimizations where you have SSDs, even field programmable gate arrays at PPAs, right? Some of these. Netezza, I use Netezza is an example, Oracle's Exadata is an example. But aside from the scale, not much changes in terms of the process flow. You still have to shred this stuff, you still have to do your ETL, and when you're doing this, time is spent here, right? You have to wait, you have to really know how you want your data to look, you have to figure out the model, what questions you want to ask. It's definitely not just putting it into the computer and asking, right? So nothing's changed there. So now people are looking at Hadoop, that part of it. I spent some time talking to customers out in the field, and they come to us, and some of them have these appliances. And the first reason they come to us is because they hit their scale with their appliance, and now for a little bit more capacity, they need another appliance. And these appliances are big. You can't just stick another node in them once the rack is filled up. You're typically wheeling in a rack or half a rack of stuff. It's like a InfiniBand on there, some fast storage, different tiers of storage speed. It's not a 5-figure or even sometimes a 6-figure purchase. It's a 7-figure purchase. So it's like, all right, we hit our capacity, let's spend a whole lot more money. So they'll come to us because they're used to hardware, but then and they'll look at Hadoop because they'll be like, all right, well, maybe we can do it with Hadoop, and we package Hadoop with what we have, and they're already using us or another NoSQL database, and they'll say, okay, well, great, I could minimize my ETL, and I can exchange it for ELT, which is extract, load, and transform, all right? But I'm still I can do batch here, but if I'm doing real-time stuff, I'm going to stuff it back into a bar. So I've only eliminated some of our ETL, but not all of it. And then they'll talk to us, and we'll say, well, you know what, that Hadoop is, that's good. We work alongside it, we can package it, but what if you had a NoSQL? So what's happening here is that there is a convergence between what has been called the operational data store, which is kind of like it came after the data warehouse terminology, but it's another sort of intersection of data, but it's a little bit more real time. There's a convergence between this concept of operational data store and data warehouse, where both ingest and conversion lifecycle really just becomes an ingest lifecycle and it shrinks quite a bit. And you move from ETL to a fancy term called wait for it. Okay. Logistics, right? But what you can also do is you can build applications on this, right? It doesn't just have to be a source. You can build an application and then it's there. And you can do discovery right at the point of ingestion. It works fine alongside Hadoop. You get commodity-based storage that is now acceptable in the enterprise. How are you doing with the backup mic? Is it like we're charging them, or?
You got two batteries in there. It's not
Okay, that's good. So the point about the Hadoop, if you see it as this way to have storage at scale, it's a very powerful tool within the enterprise. I was on a project where we had to size up our storage needs before we even know what we were building. And it sounds silly, but it's absolutely true. It happened, and you guys are laughing probably because you work in a large company where, oh, sand, yeah, give us 3 to 6 months, right? Well, and so these guys are. So if you work in a very large organization with very significant SAN infrastructure, the storage, I was going to say cartel. Yeah, I said it. I can't remember the bell. The storage group, you have to wait a long time to provision storage. So this creates things like what are called dark storage because people but it's breaking up. Okay. Another battery? Okay. The point being, well, let me sum up. It takes a long time to understand storage. Okay. Okay, so that's what it gives you. In fact, I'll talk about this a little later. So we have a Hadoop connector, but we're also an expertise. And this isn't really commercial, this is more of a commercial side. HDFS is going to be a file system for us. Okay, so let's review. This is the tell them what you're going to tell them what you just told them. This is that slide. All right, so what do we get in this data warehouse with these capabilities? We get the obvious, we get the 3 V's, we get economies of scale that we haven't been able to see before. And that's because we do it on commodity hardware. We don't have to wheel on specialized appliance. We scale at the node level, not at the rack level. So it's $10,000 or $15,000 to add more capacity as opposed to who knows what. We've minimized our ETL dependency. There's this convergence of operational data store and data warehouse, and we're getting closer to the point of origination with our analysis. Another point that I put this in here because as I'm reviewing the slides, I'm like, oh, I forgot to put the machine learning pin. Yeah, we can do that, right? So for those of you who are familiar with Apache, Hadoop, and Hadoop, there's 2 ways to pronounce that, we can do things with machine learning. And that's great for us. So this is a lot of a break point. I'm going to move to a different topic. Any questions about architecture slides I showed you about how the data warehouse is changing? Yes?
When you're talking about NoSQL databases, you mentioned FPGAs being used in some of them. It's a little crazy. I was wondering if there's any GPU stuff too, so if you're using FPGAs or whether whether accelerating an FPGA would be also accelerating the GPU.
Okay, so the question was about the NoSQL databases. I mentioned FPGAs, And it was a question about, is anybody doing anything with GPUs for search? Good, very good question. I don't know in the NoSQL space, but I can think of where it might be the case. I remember back in the grid days, remember like it's like 5 years ago, right? So platforms, Symphony, data, so they're still around. In that massively parallel scaling space, GPUs working with, in fact, I even worked with someone, we need to go or something. Okay. I worked with somebody who was telling me about, in an experimental fashion, I think IBM has set up a rack to do massive computing with one of their game GPU processors. I think PlayStation used IBM. I think that's what it was. So yeah, GPUs are absolutely being used. I don't know of them in the NoSQL space. If I'm sort of thinking out loud, maybe things like geospatial processing, right? Because they deal with shapes and polygons. So good question, and definitely something I'll look into to see if it's out there. But yeah, in terms of trying to squeeze performance out of mature and old technology, and you can sometimes just throw hardware at it, and any advantage that anybody can get is available. So I'll look into that. It's a very interesting point. And I'll also take one more before I move on to the next section and maybe get into the mic. Yes?
You mentioned about the ETL dependency, and
Yes.
You said it minimizes the ETL dependency, but it isn't clear to me like how the analysis will be done if you're not necessarily speaking to certain schema. Like how does that?
Okay, so the question was about minimizing the ETL dependency and MarkLogic being a document database. It's not clear how you can do this analysis without some type of ETL. Is that correct? So yeah, a good question. So I talked about ETL and ELT and schema on read. So ETL typically tells you have to transform stuff as you extract it, as you're loading it into your destination, and you can't do anything on it until you've transformed it already and stored it there. ELT and schema on read are different in that you can extract and load, not transform anything, and then it will transform as you're analyzing. Schema on read is you're really not doing any transforming, but you're just defining what it looks like in a virtual sense. And in fact, Hive works like that, right? In our case, we support all of the above. What allows you to minimize your ETL dependency further is that you don't have to define the schema. And it can be polyschema, right? So all of your XML can be different, right? And if you don't have a schema, like let's say you have a CSV, you could just create a random, header CSV and then row column, and then figure out what to do with it later. So I'm careful to use the term, I say minimize, because if as you work out, there's no such thing as it goes away. But it's minimizing the ETL dependencies. Is that cleared up? Okay. All right, so I'm going to shift gears a little bit and talk about some cooler stuff, newer stuff, newer cool, right? So semantics. Another show of hands. Straw poll. Anybody doing anything with semantics? Oh, all right. Oh. All right, great. So, all right, semantics. So, what does it mean? What is semantics? What are semantics? I don't know what the proper way to say that is, but it's just another way to store relationships between things, right? And there's this concept of a triple, right? And a triple just falls into this format of subject, predicate, object. And it's just a statement. It's a statement of fact or a claim. And it says, so in this example, we say Jane Doe lives in Brooklyn. Brooklyn is in New York City. Therefore, we can write a rule that says if A lives in X and X is in Y, then A lives in Y, which means infer that Jane Doe lives in New York City, right? So this is a fairly basic concept that we can all grasp. But it's not necessarily new because, and it's not just about chains of inference, but has anybody ever tried something like this in relation to this? Remember the generic cross-reference table? And I'm going to lose my hand because I'm trying to do this, right? Where you kind of modeled yourself in, okay, so we got a gentleman over there, I don't know, he kind of half raised his hand like he was on a date in the movie theater, I think. But yeah, I'm guilty. I've done this. And you've modeled yourself into a corner, but you've got this other information, these other facts that you want to stuff somewhere. So you have this generic cross-reference table. We actually store one table, store another table. The ID on that table is some relation, and the other ID. And I've done this. Only problem is, because the name of the table that you care about stuffed in another table, you couldn't even write SQL against this. Kind of have to read the table and then generate some SQL and stuff. So it didn't quite work out well. Of course, relational stuff wasn't really designed for this. Relations were things that were declaratively stated in the database. You had an ERD diagram, right? And you knew up front how everything was related and classified. So, okay, this, I don't know how I'm going to prove this next one, but this is kind of old school, but this is really old school. If anybody's ever done this, prologue, anyone? You have, okay. All right, so if anybody can tell me how old school is prologue, when was it invented, created? But
1973.
close.
68.
Okay, I'm going to go, we're going to do this like the price is right. I'm going to keep going over. 1973 was close enough. So when you move your t-shirt right there, and this is the, I shouldn't say it's the last t-shirt because I want to keep you guys here, but you know. Oh, there's one more super stuff. I have a bottle of Budweiser. So prologue actually 1972. This shows that this isn't new. This stuff has been around for a while. This language was invented, and the whole language is based on these triples and facts. And in this example, it's like, in fact, these model the same thing, right? We've got Jane Doe likes the ski. Jane Doe's married to John Doe. John Doe's a girl customer. Let's give Jane Doe a ski. Let's give John Doe a ski coupon, even though he's not a ski himself, but hasn't said that. So, all right, so here's a quick summary. Triples are units of expression. They reference the objects. They're not constrained to the part of the objects. Data separate, and for the work in prologue, there's a concept of code is data. It's a little different now. Data is here, and code is over there. But the other thing about it is that it's not just about the semantics bit. It's kind of nice to be able to create an arbitrary fact in a relationship on the fly. Maybe you don't have to infer it. Maybe it's just like, oh wow, right, I forgot to think about this. Let me assert this fact. Or maybe the fact is very transient. Like the gold customer example. That's a pretty neat tool to have. Right? Just, we can be lazy. Lazy our thinking and not modeling. I'll just put in a triple later, right? I can imagine a model gone bad where it's all triples, But, it's possible. So today, the technology for here, we've got RDF, which is a standard for on the web, right? For describing any other web using triples via XML. So it kind of works well for us. We are an XML data store. And then there's this language called Sparkle, which you can query triples. So here's an example of what RDF looks like, direct from W3 Schools. Here's an example of what Sparkle looks like from Wikipedia. I was hoping to have an RDF and Sparkle example related to one another, but just kind of ran out of time. But here, it's just created, say, find all the capitals of all the countries on the continent of Africa. Okay, so let's review. or triples the semantics, right? You can create fact relation on the fly, you can do model discovery, an easier way to tag and enrich the bound to your objects, they're kind of just floating out there in space. But you can also do inference processing, and that valuable for things like disambiguation. Right? So Jane works with Jen. Well, is she a developer or a gemologist? I don't know. Does she eat ramen noodles and have vitamin D deficiency? Maybe. So maybe she's a developer. I don't know. And apologies for any of you who love ramen noodles. I know. But, okay, so where are we? Let's do a quick comparison of the last 2 eras. Right? This is more summary. In the relational era, we have the standard API. We don't have it now. We're free to do things with our schema. This third point is interesting because, as we learned earlier, we have an ACID-compliant database. But for some reason, the expectations of ACID have been relaxed. We don't necessarily think that has to be the case. Right? We've already said we scale to 120 nodes, a scale-out cluster that is ACID-compliant across 120 nodes. It's a rule of thumb. Scale-out is a rule of thumb. Here, I'm going to talk about this a little later. There's a bit of a gap right now between, back in the relational era, with SQL, you could squeeze every ounce of information out of your databases everywhere you want. Now, we've got so much capability sitting in our big data and NoSQL stores, because we don't have a standard, we can't really get to the dashboard very easily. Right? There's a big gap between what you can do in the BI dashboard and what's that. We'll talk about that a little bit later. This one is interesting because I was talking about this today. With the SQL database, the point of integration was the common API of SQL, right? If you wanted interoperability, there was this SQL standard out there. That's how tools and things interoperate with things. Well, since we don't have that now, what has happened in the de facto way is that the file formats and the Hadoop itself has become the point of integration. Is that a good or a bad thing? I guess I kind of get it because I've thought about this. If there's so much data, you don't want to move it back and forth, then maybe that is the best thing to do. People talk about, well, is your data stored in Avro or protocol buffers? And maybe that's the right way to go. I don't know, I don't really have an opinion, but this is more of a statement of fact of where we are today. And this bit, query and search are converging. And in fact, I'm going to do a brief aside here. So, DB query and search, right? Two separate things. We've known about them for years. But inside of a database, when those technologies converge, it's a bigger deal than it sounds, right? So I have a pool, right? And a couple of years ago, I was talking to converting the chlorination into this salt-based chlorinator. Right? It's not a saltwater pool. You basically take a bunch of table salt, put it in the pool, and you attach this thing, and it turns the sodium chloride into chlorine, and that kills all the germs, and it turns back into salt, and it's this closed system, and it just kind of works. And I was like, oh, cool, no maintenance. It just kind of works. I would be in the pool store, buying algicide, my chlorine, and somebody would be like asking the pool person, hey, tell me about this salt chlorine. And I'd be like, oh, let me tell you about it. We'll jump in their face in a manic way, so excited about the salt chlorinator, because it took away this big maintenance thing, this headache of, is the chlorine always at the right level? It just worked, and it's a closed system. It was just there. And I got to thinking, like, yeah, if this is the way things were done back when people started putting pools in their backyard, we probably wouldn't be putting chlorine in our pools now. It certainly wouldn't be the fault in my mind. It just so happens that this stuff came later, and I feel the same way about database and search, database query and search as these siloed things. Because when you don't have to maintain a separate index, and when you can ask a unified question of your database as structured and unstructured, and you have to ask two questions, it is a big deal. And there's not a lot to maintain. And it sounds, again, it's my software, I guess. And I'm sure the marketing people are kind of rolling their eyes and, no, that's not the message. But it is a big deal. So let's do a quick recap. Yet another recap. It's kind of like the return of a lot of different recaps. So we can handle lots of data and all with great capability. We got triples and submerging, but we have some gaps, right? We have this big gap with what we can do in our BI tools. It would be nice if we had a standard language. I don't know if it's possible to get one, but let's imagine if we had a single language that had the declarative power of SQL with all of the context that you can imagine from the model. It's a nesting context, all right, but combined with search and semantics. We're not there yet as an industry. Right? From a product standpoint, we're building a lot of these capabilities, and we are partnering with our BI tool partners to get that capability to the business analyst dashboard. But we're just not there yet. So this is the now what part, right? So where do we go from here, right? So we've got all of this capability in the big data NoSQL space, not quite there in the BI space. It's untapped potential. We still have to write code, or we still need people who are managing the extraction of the information into something that looks relational. And so let's start with the roles, right? The application development delivery teams, what they're doing now, right? You're doing modeling, you're doing ETL, product tool integration, and you're building repeatable functions as well as your applications. How that's changing is we have to do things faster. Right? You have to create a fail fast, succeed fast environment. Right? It's another big data term. It's like you want to churn through a bunch of stuff and say, okay, yeah, this data's no good, don't worry about it, move on to something else. You want to be writing fewer ETL jobs and deal with things. But again, this is the big takeaway here is there's a gap that we have to bridge. We have to bridge as technologists, as an industry. And that's where I personally see things changing in the next 12 to 18 months. Is the BI tool vendors and the NoSQL vendors and the big data space, we need to get that into that hello computer. We can just ask the question and get the answer. Quants, actuaries, and related, right? So, are there any quants or actuaries in this room? Okay. Is that right? Back there? Yeah? Okay, yeah, we got one back there. All right. So, yeah, these are the map business, right? And they do things like pull signal from the noise, deep data mining, and then code, right? And they're in the big data space handing off data to the BI folks. They say, oh yeah, I found something interesting here. Here it is. The dimension, or here, I'm going to throw it into the NoSQL table and go take a look at it. Oh, not interesting? All right, let me find another one. Right? Well, that's, we're hoping that changes. Well, the first thing they're going to do is they're going to change their title to data scientist because you probably get a raise. If you haven't done it, make sure you do it. But hopefully spend less time coding in a traditional sense, right? And basically spend more time analyzing. And continue to identify the new sources of mining data. But what we really want to do is we want to put forward that into the BI analyst role. Because really they're running reports with the SQL dialect, and why let the quants and analysts have fun? Which let's have the quants and actuaries, let's have the BI analysts have fun as well. And expand how they're analyzing the spatial, and be able to do some more, lighter weight data mining, right? Because it's an iterative discovery process, and now there's this concept of enrichment, right? As you look at things, say, oh, that's an interesting fact, let me tag that so I can analyze it later. From an industry standpoint, this is essentially what I've been talking about quite a bit. Maybe some standards, right? There's public data sets that we can take advantage of. It's not only the data that's within our organization. because what's valuable is some of the data that's out there on Amazon or wherever, and widely pertinent. It's tons of data. So there's a lot more in the way of external, not feeds, but things that we want to analyze in real time. A lot of the enterprise are building some of their own capabilities, right? Because you don't build big data in a vacuum, because you're talking about thousands of nodes. There's not a single line of business that's going to own that. So it's typically a horizontal organization, a horizontal slice of the organization. And yeah, standards. I think we need more standards, and at some point we'll get to that capability to the Benari tool. So, okay, so I've kept to a very mostly advertising-free presentation. We'll do a quick word from our sponsor. So, what is MarkLogic? And if I had put this up at the beginning, you would have had most of the trivia questions, right? We're ACID compliant. We're the only enterprise NoSQL database. And enterprise, we spoke to the folks at Gartner, and they said, yes, you can save this because you have all the stuff that is typical in the commercial relational databases where you have it in a NoSQL database, and you've had it for 10 years, and you can do all kinds of stuff. And this is another slide where we have this one data store and lots of other responsibilities. So you can be an operation with EVMS. You can do analytics directly off of it, unstructured. You can search, event process. It's something we didn't really talk about much, but do that as well. And it's all one technology. And if you are interested in taking a look at it, I suggest you take a look here. Right? Take a look, take a picture, or just go to our website. It'll be easy to find. And I'd like to close with, this is more of a thought before we go into the questions. Think about how you would bridge the gap, right? Unless you really feel that all the capability of big data is available at the touch of a button, what would you do? What do you think the industry should do? And drop me a line if you like, or if you want more information. That's me, MarkLogic.com. And I'll turn it back over to Eric for any questions.
Before we move on to the Q&A, that was exactly what I was asked for. Nice, kind of beat me to it. I was about to say, let's hear a great big round of applause for the Chief Field Architect for MarkLogic, Ken Krupa. Thank you. And for Q&A, please fire off the first question. Hands? You in the back.
You talked about semantics and triples. You never actually used the term graph database. So I guess my question is, how do you feel about graph databases?
Yeah, so in the NoSQL summary slide, you're correct. I think there's a bullet point on it. Yeah, that's what graph database is itself, because it stores pointers to other objects. A single-purpose database, I believe that the best NoSQL database is going to be a convergence of what's good about all the above. And so we're not a graph database per se, but in version 7, this was announced at MarkLogic World recently, we're building a triple store into our database. So it wouldn't classify us as a graph database in the traditional sense, but I think all of these tools are important. I don't think one of these factors.
Yeah, I've heard from hybrid models of object and graph databases. I find that object stores are very nice for objects, and the graph database is a nice relationship.
That's right. It's a very good point. I just believe we need both. I don't think you can look at everything as objects, because things like analytics, when you're crunching stuff, you really want to slice through it all. And I'm not sure. I haven't performance tested some of these graph databases, but it just doesn't feel like it would be the best thing. You have to have aspects of that involved.
Next question. Right here in the front. Oh, sorry, we're pointing to the people.
I saw you mention, MarkLogic can also be used as a search engine. So I was just thinking in terms of like the existing search engines like Solar, how do you think, it differentiates itself from Solar, when it comes to search engine functionality?
Okay, so the question was about how MarkLogic can also use a search engine and other search engines with Solar and how we differentiate ourselves. And I think the key thing is that we're not just a search engine. We give nothing away in terms of leaving features out of our search capability. If you looked at us by search capabilities alone, we go up against just about anybody. And in fact, we've replaced search-only technologies in some places. Things like fast and similar. So I think our value is that you can do it all. It's not a compromised technology. It's not like it's an okay database, an okay search. It's a really good NoSQL database and a really good search engine because it was built from the ground up with this reverse index paradigm. And stuff is indexed on ingestion. So it's almost like our database is built on search technology. And in fact, our founder, Chris Lindblad, he came to a search background. He wrote the infancy. He basically built a better engine with the transactionality and database as well.
So the next version
Well, we won't forget it. The guy in the back has his hand up.
Oh, yeah, so, Kevin, we both work with financial industry and we work together. What office technology specifically, which is highly, for the most part, highly structured data, how does big data or NoSQL help with that fashion? Or something that's very specific, very something like time series data. Are there things that how does how do I compare this? My boss is saying, look, I know you dealt with relational for 20, 30 years, and you have all the resources, but this is where.
Okay, so I'm going to try to summarize that question. So Sean, Sean and I worked together one time. So full disclosure, I did not plan to give us that question. The first half of the question was, so we talked about NoSQL and these unstructured, polystructured databases. How does that work in the financial services space where a lot of the things are heavily structured? Is that right? That's the first part. And then the second part is when you're doing something like time series analytics, how does that work as well? So for the first half of the question, it's going to sound like I asked that question, but for the first half of the question, we have a great answer. Financial services in particular, especially with the explosion of derivatives, are very complex structured instruments. And they don't really model well. They're heavily structured, but they're deeply nested. So a trade will have multiple legs and cash flows to it. And in fact, it's probably why the standard, the industry standard for capturing derivative information, FPML, which is the standard, is based on XML. And if you go to the ISO website and you look at some of the FPML definitions, you'll see these deeply nested trades with this. So they actually map really well to a complex structured database, like a NoSQL database. And I urge you to look at the second half time series. We absolutely do that as well. Do we do it as well as a purpose-built time series engine? Maybe not. But in those 80% of the cases in the middle, we absolutely have these analytics functions. In fact, in MarkLogic 6, we have the capability to create what are called range indexes, which are small slices of your document. And date and time can be a range index. And you can do these analytic functions against those range indices. And we have some built into the database, and you can also write your own. So, the short, non-marketing answer to the time series question is yes, we absolutely do it because our financial services customers who are now using us, and we have one who's now using us as a derivative trade store, are going to need to do that type of analysis, and they prefer to do it in the same place as opposed to having to put it into a purpose-built, say, time series engine. you know, if you're purpose-built for something, you're going to do a better job. We do a lot of things very well.
Okay, almost out of time. Next question. Yes?
Have you heard of a database called Atomic, and what's your opinion on it?
This is an easy one. No, I have not heard of the database called Atomic.
So it's by a machine keyboard method closure.
Oh, okay. Is it built on Atomic closure?
Now he's working on the Atomic.
Okay.
It's basically like coming up with a complete list-based solution for it.
Okay,
You
so,
got back-end language, your front-end language, and now your database.
see, if I had another teacher, so I had to run up things like the list, that's more old school AI stuff. No, I haven't, but I'll definitely take a look at it. Email me and I'll give you my opinion. Give me a couple of days, though. It's a long weekend, and I already have beer in my hand, so.
Okay, last question of the evening. You had a question?
That's cool. Last question.
Actually,
Yes.
I had another question regarding the semantic, the web actually or semantics, and you mentioned the next version is going to be a triple store is going to be implemented in the MarkLogic database. I was just thinking, I haven't been able to find a solution that can scale and also do search in the semantic data, especially free text search.
Right.
So is there anything in the pipeline or can you give me more insights?
Yeah, so what I suggest you do is grab our early access of 7, or shoot us an email. Maybe I spoke a little too soon. How we do the early access is a bit controlled, but certainly shoot me an email, and we'll look into doing that.
Sure.
The only thing that concerns you about the early access is that how do we testing at scale. When we go GA with it, when we put these things in, we build them to scale, so we won't release them. And that's the whole point, because you could model semantics with a document database if you wanted. You could add these metadata fragments and put a relationship in pointing to another document URI and do the reverse. But the whole point of the triple store is to do that at scale and to do it efficiently. So, we'll have to prove that when it comes out in GA. But yeah, that is the whole idea, and it's a very good point in that it'll be the database query that you expect, the structure query that you expect, the search, 10-year-old search technology, very mature, and the special semantic triple store index that we're going to have.
And I don't know exactly what's going to happen, but right now for MarkLogic 6, which we launched last fall, you can actually go onto the developer community on MarkLogic.com, to the developer side. You can actually download MarkLogic 6 and work with that. It's a free download. It's the reference that Ken made earlier. So my guess is there'll be something similar for 7 as we get closer to that.
Yeah, definitely take a look at 7. The official line that we've heard, and I've heard our founders say in front of customers, check with our CTO, is sometime in the fall. That's the best I can say about 7. But that's soon. And customers of ours have the early access really soon.
Okay, for those who didn't get questions in, Ken will be here for one-on-one questions afterwards, so don't feel like you got left out. Please give a great big round of applause to the CTO.